Hello, everyone. My name is Duan. I'm a second-year PhD student from Rutgers University. Today, I'm presenting our research about New York City street cleanliness. One of the reasons we start this project is that New York City government performs a cleanliness inspection every year by relying on inspectors' subjective judgment during their visual inspection. So this method hasn't changed for nearly 50 years. The readings are adjusted for street miles, but not for population, housing density, or the nature of the activities in the inspected area. So based on the current reading, New York City government reads the majority of its street as acceptably clean. However, as you can see from this chart, from the inspection report, majority of the communities in New York City for the year of 2019 were rated above 96%. Even in prior year, they were rated above 94%. However, the residents increasingly contact Department of Sanitation via 311 to complain or request for services about missing trash pickups, overflowing litter baskets, and dirty conditions. As you can see from this dashboard, based on last 5 years 311 calls, you can clearly see an increasing trend of complaints or requests for services made by the residents. The top categories are requests for large bulky item removal, rodent, and graffitis, and so on. So it's valuable to find another data source to validate the government's inspection readings and to assess people's opinion about New York City's street cleanliness. An alternative data source, Twitter, was identified in this case. So the objective of this study is to examine the social media information to identify the temporal trends and the patterns on how people perceive the cleanliness of New York City streets, subways, as well as how people feel about the street parking conditions. In addition, we also wanted to evaluate whether public opinion is consistent with the New York City's cleanliness readings and assess the sentiment expressed in the tweets to measure the public opinion in order to provide a valuable insight regarding the performance of municipal services. So a sample of the tweets that we examined are listed here. So the use of social media has grown significantly over the years. The number of users has increased exponentially. As you can see from the graph below, the number of users increased from about 10 million in 2010 to over 60 million in 2019. People are adapting this type of communication channel rapidly. To put things into perspective, Twitter generates about 500 million tweets each day, and Facebook has about 4.75 billion. So this massive amount of data is desirable to many people. And many researchers found that social media information, such as tweets, can be utilized as a non-financial indicator. It has predictive power. So the researchers have studied the impact of tweets on different areas, such as using Twitter data to enhance the substantive analytic procedures, use Twitter sentiment to predict stock returns, assess the impact on presidential elections, study the effect on consumer behavior and marketing sales, and so on. Also, many cities, such as Boston, San Jose, London, try to use the crowdsourcing or the wisdom of a crowd approach to address the street cleanliness issue, such as using a mobile cloud-based app or a dashboard. So citizens or the residents can simply take a picture of the streets, dirty conditions, or potholes to post it to the app or the dashboard. So many researchers explore the use of the crowdsourcing, such as in consulting business models, in accounting, finance, management, even for data analytics. So social media is the perfect platform for gathering crowdsourcing information. It has a rich source of data that are coming directly from millions of users. So that being said, the workflow of this project is showing here. First is to collect the data, then prepare the data set to a machine-readable format. The third one is to identify the relevant tweets before applying a sentiment analysis. And I will go over each step in details in the next few slides. First, we're using Twitter API to collect the data. There are two types of API that Twitter offers. REST API allows a user to retrieve specific users' tweets, but it only allows users to go back in time for approximately 1 week. Stream API is a forward-looking and collects upcoming tweets. It's generally the preferred way of downloading a massive number of tweets, but it's time-consuming. So in this study, we use a Stream API to collect the tweets based on New York City's longitude and latitude. And all tweets coming from this location were captured. And the different Python libraries are used during the tweets collection. So total about 6.8 million tweets were collected from August 2018 to May 2019. Then the next step is to pre-process the data to a machine-readable format for analysis. First, we use a C script to remove the corrupted records, quotation marks, dots or commas, and so on. Then the next step is to select the relevant attributes. Then we use MySQL to store, organize, and combine different data sets into one single CSV file. Because the data was collected based on New York City's longitude and latitude, so there are many irrelevant tweets in the data set. So this step is to determine the relevant tweet to the subject. So first we apply a keyword list. This would filter out some of the irrelevant tweets. Then the next step is to perform data pre-processing, such as tokenization, convert the number format, remove the URL links, hashtags, stop words, perform lemmatization, and so on. So now the data set is ready to apply machine learning algorithm. So first we tried unsupervised machine learning based on the topics of the contents. So we use LDA, which is an example of topic modeling, classifies the data set based on different topics. However, this approach could not provide a clear separation between the relevant and irrelevant tweets to the study. So then we decided to use a supervised machine learning algorithm to identify the relevant tweets. So 26,000 tweets were labeled manually as our training set. 3 different classification models are used: naive Bayes, random forest, and XGBoost. And the results are listed here. Based on the accuracy rate, the performance of each classifier is great. However, the results indicate that the data set is facing an imbalanced class issue. Additionally, the false negative, which means that relevant tweets are classified as irrelevant, is quite high. This caused the recall ratio to be low. Recall is to measure the classifier's completeness. It indicates the ability the classifier can capture all the positive tweets. So low recall will be corresponding to high number of false negative. So to resolve this imbalanced class issue and low recall, we use a 2-sampling method: random undersampling and random oversampling. Random undersampling aims to balance the class distribution by randomly eliminating some majority class examples. Random oversampling aims to balance the class distribution by randomly replicating the minority class examples. Then we use the stratified tenfold cross-validation with a pairwise t-test to evaluate the performance of each classifier based on different measures. So for an imbalanced data set situation, we want to focus on the recall number as well as the walk AOC. In this case, the performance of random forest undersampling and XGBoost oversampling are very comparable. So considering the computational requirements and the cause of a misclassification, XGBoost oversampling deems to be the reasonable classifier to use, as it has the highest ROC AOC and relatively high recall ratio. So I also performed a manual validation on a sample basis. 1,000 tweets are randomly selected and labeled manually, and the results also indicate that XGBoost through oversampling performs the best, followed by random forest. So in terms of the data size, the initial collection is about 6.8 million. After applying a keyword list, the data set is down to 132,000. Then after the classification models and sampling method, the final data set that contains a little bit more than 8,000 tweets. Then the next step is to perform a sentiment analysis. Considering the unique characters used in the tweets, such as punctuation, capitalization, emoticons, slang, we choose a Vader, which is a lexicon and rule-based sentiment analysis tool that is specifically attuned to the sentiment expressed in social media. And we also separate the results into different categories: streets, subways, parking, and homeless. As you can see from this dashboard, the overall sentiment is negative, and the majority of the negative sentiment is related to the street condition. Compare the results from the tweets to the inspection report, you can see the discrepancy between the two. This could potentially raise a red flag to the authorities to reconsider their approach and evaluation about the cleanliness of the city. Also, we extend our framework to another social media platform, Facebook. 15 Facebook community pages were selected and 29,000 posts were extracted. So we use the same methodology as a Twitter dataset. However, the majority of the posts from Facebook are not relevant to the research topic, even though the posts are related to street conditions, parking, or homeless. So the posts are more of a generic announcement of a particular event or activities rather than a person's opinion. So this is why you see majority of the posts are neutral here. So all the posts are evaluated individually to identify the true relevant post to the research topic. So locational information is exempt from the negative and the positive posts. So based on this supplemental study, we conclude that the incremental value of Twitter and Facebook is different, at least to this research topic. They contain different type of information, even though they're both social media. Also, it's important to identify the appropriate data source to the research subject. In this study, Twitter provides more valuable information than Facebook. So this could be a potential future research and compare the different data sources such as Twitter versus Facebook individual users post rather than a community pages post. So in conclusion, in this study, we established a framework that could be potentially used for continuous monitoring New York City street cleanliness. It applies text mining techniques to Twitter information, use a different machine learning algorithm to analyze relevant tweets, assess the sentiment expressed in the user-generated content to measure the public opinion about the cleanliness of New York City. And we hope this study could provide a valuable insight to the authorities regarding the performance of municipal services. And thank you very much for your time.